Hello, my name is Yevhen Kostiuk, and today I'm going to present our paper, Framing the Language, Fine-Tuning Gemma 3 for Manipulation Detection. So this paper explains our approach for shared task in manipulation detection in Ukrainian social media, and it handles two subtasks of span identification and technique classification. Span identification is a binary span detection task, which basically this challenge is addressing extracting subchunks or substrings from the text that contains manipulations in them, without specifying which manipulation do they actually contain. Technique classification is a task of multi-label classification task, and the challenge is to assign one or multiple labels to the text, and the label itself indicates which manipulation the particular text contains. In total, there are 10 different manipulations that were presented. Loaded language, written generalities, euphoria, appeal to fear, food, which is fear, uncertainty, and bandwagon, cliché, whataboutism, cherry picking, and strawman. The dataset looks as follows. So we are presented with a text, in this case a Telegram post in Ukrainian or Russian, usually about the war, and we don't really have any images, video, audio, even though sometimes it has mentioned that video is taken from the channel, as in this case. And for technique classification, manipulations are assigned to it. So in this case, it's euphoria and loaded language. For span identification, we see that there are subchunks labeled as being manipulative, but without explanation which manipulations they actually contain. So in total, there are 3,800 samples for trained or public leaderboard dataset, for open dataset that you can use for training. Additionally, there is a language identified available only for train. So as you can see, there are 2,000 posts in Ukrainian and 1,600 in Russian, and 67% of all the posts contain at least one manipulation, while 33% they contain no manipulations. For the private test, there are 5,700 samples, and there are no language identified presented in that dataset. However, we estimated it with automatic language identification pipelines, and we estimated there are 3,000 samples in Ukrainian and 2,500 in Russian. So in the next section, I will explain the methodology behind the technique classification for our solution. And as a base, we used Gemma 3 model with additional classification head on top of it, which consists of attention and feed forward, as you can see highlighted red on the slide. It outputs a vector of logits for each manipulation, or kind of like a certainty of whether this label is there or not. And, well, the final vector has dimensionality of 10. So for each manipulation, it has a dimension. Before we trained, we separated our trained dataset, well, publicly available dataset, into train and dev, with 80% going to train and 20% going to dev. We trained models for 10 epochs and selected best on dev split. Overall, for learning rate, we used 75 for the original Gemma layers, and for our custom one, we used 2E-6 to train it. So our training process consists of 5 steps, and the first step has been, well, basically training base classifier on original trained data, the ones that 80% of publicly available data, and, well, receiving that model. The next step is to take a 400K available dataset of Ukrainian news that contains both Ukrainian and Russian in it, and marking or pseudo-labeling this dataset with existing models that we trained on original data on previous step. After that, we separate this dataset into 2 equal chunks, or roughly equal chunks, and we train same models with the same architecture, this LLM-based classifier, on them, and evaluate them on the dev dataset that we have. The best performing model is then used to pseudo-label the chunks that didn't see So, for example, in these cases, if you selected the model on the right, it will actually pseudo-label the chunk that was used for training the model on the left. We refer to it as a model 2. And finally, with this data, we train another classifier of the same architecture to classify manipulations, but on that pseudo-labeled chunk, only on that. The final solution is models 1, 2, and 3, and we ensemble them with random forest classifier. So we use their logics to fit random forest, and that was our final solution that we used for predicting on the private leaderboard. For span identification, we used very similar methodology with the same hyperparameters, but without multi-step process. We train the model to make a binary prediction on whether the particular token is a part of this manipulative subchunk or not. So basically, the model outputs a binary label for each token on whether it is manipulative or not. Here's our result. For instance, for technique classification, we received 0.43 F1 macro on public leaderboard, resulting in 3rd place for us. And on a private leaderboard, we obtained 4th place, and with a result of 0.45, which is slightly better. For span identification, we received 0.459 span level F1 for both public and private leaderboards, which gave us 4th place in both cases, which was pretty consistent. Additionally, for technique classification, we experimented with other models. So you can see the list here. And as you can see, the ensemble model provided the better result on dev overall and private leaderboard as well. So interestingly, we experimented with augmented, generated, or paraphrased data. So for paraphrasing, we used already existing posts from the trained dataset. And, well, we basically paraphrase them with Gemini, but with a twist of asking Gemini to preserve the spans. So it had to output the specific tokens before and after the manipulative span. It had to paraphrase it, but it had to keep the manipulative part in it. As you can see, it didn't help that much. From all of it, it's actually made it worse. Then model just fine-tuned on the original data. For generating data, we actually used existing datasets of Ukrainians and Russian news from the 2023, starting from 2023 and forwards. And we asked the model we analyzed topic distribution of them and different styles that were used. For example, we automatically detected those styles with LLMs. So for instance, like aggressive style, blaming style, like there were a bunch of styles that we used, and we asked the model to generate Telegram posts with this particular style and with this particular manipulation techniques involved, with again providing a specific marker of each span where it is. So we tested that, and as you can see, it also didn't help a lot. So the model doesn't really understand that. We use Gemini for both cases, and as we can see, the model is not really improving if we throw generated and paraphrased data to the pool of original data. So at the end of the day, the quality data matters in our case. So yeah, that's it. Thank you for your attention. The code is available via the link that you can see on the slide. And if you want to contact me or other authors of the paper, you can use email below. And again, thanks for your attention.